Now, in this particular, as I have shown you one pattern, this is the pattern you have seen. Now, let us bring the another program. Let us show you the another program. Based on that, how the loop will going to run. So, see here, this is the program what I have done. Program on your, just a minute, program on the base of this program. This program I'll show you later. This is the program I will going to show what the print the prime number from 1 to 100. Okay, so prime number from 1 to 100, how it will going to print. See here, I have taken a loop, is a for loop for n in a range of 1 to 101, because what I have said you, that if you give a condition in the for loop, that starting address whatever it is, but ending address, if you specified the ending address in this way, that means this particular ending address you will going to find it, that in this ending address, that it will do one step before of that. That means one step before of the ending address, it will going to run the loop. Now count equals to 0. So I put one counter here. Counter is 0. Now again another inside loop I have started. What is that? For I in range to n minus 1. Okay, to n minus 1. So if n divided by I equals to 0, okay, then what it will happen? Count equals to count plus 1. Break. See, I have used the break statement. Break statement use I have shown you previously in my previous videos. You have seen how to use the break statement, how to use the return statement and all. So here the work is been conducted. Now count equals to 0 and n not equals to 1. Now let us run this program and see what the output it is showing. So program output, see the output. First prime number is 2, then the prime number is 3, then 5, then 7, then 11, then 13, then 17, then 15, 23, 29, 31. So similarly based on that, 97 is the last prime number which is divisible by itself, and 1. Prime number, I think you know, the number which is divisible by itself and by 1. So those the number which are divisible by itself and 1, that are the number is known as prime number. Like 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, as well as 67 is a prime number, 97 is also the prime number, 89 is a prime number. So all these things you can see it, those are the series of prime number that are printed here. Now in this particular prime number series, what you will going to see, that here the loop has been taken. Starting point, as I have said to you, that once if you don't say anything, that it will start from 1 or 0. Step not required here, because I am giving, if you are done defining the step at the last, it will by default what it will go, yes, it will go 1 in each steps. Okay, now see this inner loop, what has been done for uh, I in range. I have started from 2 n minus 1. Okay, so I in range n 2 and n minus 1. So here I am taking out if n divided by I equals to 0. If it is 0, then what? Count is increasing. Count is becoming count plus 1. Okay, count is becoming count plus 1. And then what it has done now, if condition. So 2 for condition, 1 if condition. If count equals to 0 and n not equals to 1. This is a not equals to sign, not equals to 1. So if it is so, then it will going to print the value of n. That means I am taking the value from here. As I am taking the value from there, this particular value, what you find it, that the value will going to divide. So what I am saying, that is it 0? No. And is it divided by 1? If it is not equals to 1, then what? That is a, that to be printed out. So it is based on this particular properties, or based on these particular conditions of the loop, it is printing out the loop and it is giving the outcome of this particular loop. What you are finding it, that there is the different series of prime number from 1 to 100. Okay, so this is how the prime number is printed. This is how I am printing the prime number, and I am showing that whether this particular prime number is what, they are the number or prime number from a certain range. So It is a program. In this way, you